All right, here is 7.3. Okay, so that took care of 7.1, 7.2. That's all you're going to have out of those sections is what we just did. No composites, no mixing, no regular and inverse together. That's it. Okay, for 7.3, you're going to have two equations that you have to solve for. Okay, so remember, it's going to give you an interval. So all we're looking at is the unit circle. Okay, here we go. Here's one equation. 2 cosine squared theta plus cosine theta minus 1. This is a quadratic. You're going to have to factor him. If you're not comfortable doing this, replace your cosine with x just for a little bit until you factor it. Then once you solve it, you can put the cosine back in and go to your unit circle. Okay, if you don't have to, then don't worry about it. But that's what I did. Okay, let me make sure there we go, focus. This loves to get out of focus. Okay, so we want to factor this. If you're good at factoring, take off. Okay, here's what I noticed. I'm going to have to do 2 times -1. Okay, that's a -2. I need factors of -2 that are going to add together to give me a +1 in the middle. So I know it's going to be 1 and 2, but somebody's going to be positive, somebody's going to be negative. And we want a +1. So our 2 is going to be positive and our 1 is going to be negative because they'll add together to give me +1 and they'll multiply to give me -2. Everybody agree with that? Okay, I'm going to put little X's on them in the back. Okay, and remember, I'm going to replace my middle term with them. That's all I'm going to do. You can do it in any order you want, but I'm going to throw them in just like this. Okay. All right, we said that's legitimate math because I could combine these if I wanted to, and I'd go right back to here. But the reason I did that was just to help me factor if you need a little help. Okay, now I have 4 terms, so I'm going to group. Okay, I see a GCF here of 2x. If I pull 2x out of each of these terms, I get x plus 1. All right, what would be my GCF for this guy here? -1, good. If I divide both of those terms by -1, I get x plus 1. That's your checkpoint. They better both be the same. If they're not the same, you made a mistake. Now you're going to pull one of those out like a GCF and write what's left in the back. Okay. Now we're going to solve for x. Okay. So this guy's really easy to solve for. He's a nice little -1. This guy, you might need to set equal to 0 and solve. I'm not sure what your equation skills are, but you should get x is equal to 1/2. Okay, so I have a -1 and I have a 1/2. Everybody okay with those so far? I'm not done though, because I had substituted, right? I substituted x. So I now have to go back and say, actually, just kidding, cosine theta equals -1. And actually, cosine theta equals +1/2. Okay, what you got?
What happens if we forget to do that?
Well, you didn't solve the equation, so you'll get a few little points.
Okay.
Just a few. Okay, so now we're going to look at our unit circle and see, okay, where is cosine equal to -1? And where is cosine equal to 1/2? Now, this is not an inverse situation. You have the whole thing at your disposal, okay? So I'm looking for cosine of -1. Here he is. Cosine's -1, so that would be pi, okay? So for this guy, theta equals pi. That's the only value on the unit circle that will satisfy that. Then I come over here, and now I want to know where is cosine +1/2. All right, well, pi over 3, but then there's also 5 pi over 3, because there's 2 places where he's positive and 2 places where he's negative. So I need both. So pi over 3 and 5 pi over 3. So it turns out there were 3 answers for that equation, and you're going to need all 3 on there, okay? So he's just a quadratic. You substitute for x, factor him, plug it back in once you have your x equals some numbers, and then go to your unit circle. And everywhere you see that value, that's an answer. Okay? Is that okay? Yeah? Okay. All right, let's look at the next one. Okay, the next one's not a quadratic. He's just a good old equation, linear equation. So you could leave sine theta right in there for him. It's not really necessary you substitute unless you just like to do that. So I'm going to subtract 1. And I get -3. Okay. Then I'm going to divide by 3 root of 2, because remember, I'm just trying to get sine theta by itself, just like you would an x. You're trying to isolate it. Okay, now notice what's happening here. My 3's are going to cancel, right? And I'm going to have a -1 over root of 2. Can I leave that? No, I got to rationalize again. So I'm going to multiply top and bottom by root of 2. Negative root of 2 over 2. So what I have is sine theta equals negative root of 2 over 2. Okay, is everybody okay getting that far with that guy, with that equation? I just solved for sine theta. Okay, now we're going back to the unit circle, and we want to know everywhere that sine is equal to negative root of 2 over 2. How many answers are we going to have? 2, right? Because there's 2 places where he's positive and 2 places where he's negative. Okay, so here we go. All right, sine's the guy in the back. So we're going to have 5 pi over 4 and 7 pi over 4. And those are going to be my answers. Oh, it is. Yeah. I knew if you could just tough it out through my math lab, when you got to the test, you'd be okay. Because the test is just little tiny tidbits. It's not like, let's kill children. Yeah. Okay. All right. Is that okay with your equations? Those are the 2 types you'll have, just like that. Okay, so that's your 7-3 material. All right, 7-4, it's a little heavy on 7-4. It's a little heavy on identities and things. You actually have 1, 2, 3, 5 of these plus a bonus that's going to come out of 7-4. But don't panic, because if you have these down, what I have put on the board, you're going to be fine. And each little one comes with a hint, like, let's do this, let's try this. So all you have to do is kind of follow the hint. You're not just left to your own devices, because who knows where y'all would end up, right? All right, so here we go. Let's do some identities. So first thing we want to do is establish the identity. That means make this left side look like the right side. So you're going to stop when you get to sine squared theta. Okay, it's always nice to know where you're going to end. All right, so if you need a little hint, here's your hint. Write in terms of cosine and sine. So we're going to only deal with this side, and we need everybody over there to either be a sine or a cosine. That's it. Okay, so, well, this is already sine, so I get to leave him. How could I write cosecant as a sine or a cosine? Right down there, right? He's actually going to be 1 over sine, right? There he is. And then I don't have to change cosine squared because he's a cosine. All right, so I followed the first step. All right, let's see what I can do to him then. If I combine these guys, or I really don't even have to combine them, what's going to happen to these 2 terms? They cancel. Does everybody see that? What am I left with right here? And don't say nothing. 1. Okay. Good. Okay, remember, when we get to sine squared theta, we can stop. Okay, now the next hint is make a substitution using the Pythagorean identity. So we have 3 Pythagoreans over there. Everybody see those down on the very end at the top with the squares? So I have 1 minus cosine squared. Okay, so if I take that top one and I solve it for 1 minus cosine squared, I'm just subtracting cosine squared over, what am I left with? Sine squared. And where was I supposed to get to? We're done. We're done.
Do you want us to write that down to like show you that we use that?
No, you don't have to tell me how you did it, as long as this is what I want to see right here. I want to see those three, just those steps right there. That shows me how you did it. Yeah. Because I'm going to know that that's what you did. I mean, technically you are supposed to write down for every step. If you had pre-calc, you know, you had to do that. My math lab likes you to do that. I'm kind of like, let's just get the show on the road, right? Okay. All right. Let's try the next one. Okay. Simplify the expression to a single trig function. Okay, so this is how you know when you're going to stop. You're going to stop when you only have one trig function. That means one of the big six. As soon as you get there, you're done. Okay, gives us a little hint. Put it in terms of sine and cosine. Okay, well, here we go. Nobody's in terms of sine and cosine. So if I look down there in the end, what can I turn cosecant into? 1 over sine. Okay. What can I turn cotangent into? Oh, well, in terms of sine and cosine. Cosine over sine, right? Okay. And then what can I do to secant? 1 over cosine. Okay, so far everything that you need is up there. All we're doing is we're writing them in terms of sine and cosine. Okay, let's do a little combining then. Let's make our numerator a little nicer. He's going to be cosine theta over, what's sine theta times sine theta? Sine squared theta. Pay attention now. Where does that square go? On the word, right? Put him on the word. Don't put him on theta. Okay. And then we still have this dude in the bottom. Okay. Now, it doesn't give us any more hints, but we're trying to get to one function. So we have this super funky complex fraction. What do we think we should do next? How about keep, change, flip? How about if we make this one chunk? Okay, so let's keep, change, flip. We're going to keep the top just like this. Change to multiplication. We're not going to have 1 over cosine. What are we going to have? Cosine over 1, or just cosine, whatever you like. Okay, let's keep going. Let's make it one little chunk. What's cosine times cosine? Cosine squared theta. And now he's over sine squared theta. All right, we want to end up with one trig function. Now he can be a squared function, but we only want one word. Perfect. So our answer is going to be cotangent squared theta. That's going to be our answer. We wanted one function. So notice that's why I put that down there. If you know that the singular works, if you know that cosine over sine is cotangent, when you square them all, it's also the same thing. But a lot of students have trouble making that leap. So write him down if your brain is not really making the leap there, but then you're done. Okay. All right. Okay, everybody good? Okay, now we're back to another establish. That's great, because at least we know what we're looking for in the end. I always like an establish. So what we're looking for is we're going to stop when we get to tan squared theta. All right, it says use Pythagorean theorem. Well, we're not quite ready yet, because in order to use Pythagorean, we need some squared terms. I don't have any squared terms. So what do we think our first step is going to be? Let's FOIL. Let's FOIL. So we're going to have secant times secant, secant squared theta. We're going to have a secant times a 1, so that's plus secant theta. We're going to have a negative 1 times secant, so now we're subtracting. Oh, that's nice. We're going to cancel the middle. And last but not least, we have a minus 1. Okay, so the middle cancels, and I have secant squared theta minus 1. Okay. Once you get to this point, you're ready for that hint. You're ready for a Pythagorean. So if I go look at my 3 Pythagoreans, I'm going to use the one that contains secant and tangent. Okay, so over here on my left, the left is what I'm allowed to change. If I look at that middle one, if I take secant squared theta and I subtract 1, what am I left with? Tan squared theta. Does everybody see that? I'm just using Pythagorean down there, the middle one, and I subtract my 1, and that's exactly what I wanted. And that's how I made that leap. And then I'm done.
Would it have been wrong if you took that problem right there and said +1, so it would have been tan squared theta +1?
Oh, if you added the 1, I would take it, but technically you're not supposed to be doing anything on the right. It's like the right side doesn't exist. Yeah, you're supposed to just be on the left. So she said, what if I, because you know, it makes more sense in your brain if you add the 1. So she's saying, what if I noticed if I added 1, then that equaled secant? I'll take that because that you established it, but technically speaking, you're supposed to leave the one side alone. That's all. Okay. Okay, everybody good with that one? All right, 2 more, and then we got a bonus. Okay. Okay, here we go. We don't have an establish, but we have multiply the following and simplify. Okay, this is when you're just going to have to, you're not going to have this exact one, but you're going to have one very similar. So this is when it really, I can tell who studied and who didn't, because those that didn't study don't know where to stop and they don't know where to end up. So you got to be careful here. Okay. Oh, I marked Alejandro here. He's not even here. Okay, just noticed that. All right, so we're going to multiply. All right, here we go. You know, I like to seal everybody off. I don't like anybody left out. Okay. Now we're going to multiply. So I'm going to have sine theta. All right, you can decide if you like sine theta or cosine theta. That's up to you. Okay, either way. Oh, you know what? I just did that and I was supposed to leave the top separate. That's okay. I mean, you can do it this way, but you don't have to. If you haven't done it yet, you might just want to leave them separate. I'm going to show you, you're going to live anyway because we're going to pull it out.
Why can't the right side be 1? The 1 plus cosine.
Oh, and then it would make your life easier.
Yeah.
Yeah, well, I don't want your life to be easy-ish. Okay, all right. So then we're going to multiply our denominator. So we're going to have 1 plus cosine theta minus cosine theta. Got a cancellation there. Minus cosine squared theta. Okay. We're going to cancel there. All right, so again, if you didn't multiply the top through, you're actually a step ahead, but I did just because I can't help myself. I'm always wanting to distribute. But we'll fix them in a minute. Okay, my denominator is going to be that. All right, now here's the point where you're going to have to make the leap on your own because it's not really going to tell you what to do. Anybody have an idea of what kind of leap they want to make for the bottom? What might you want to do with 1 minus cosine squared theta? Let's change it to sine squared theta. A huge way to simplify something is to take a denominator with 2 terms and make it 1 term. That's huge. So this hopefully will ring a bell in your little mind to go Pythagorean. And then if you look up there at the top, 1 minus cosine squared theta is going to be sine squared theta. Okay, now the reason I said I shouldn't have multiplied the top is because if I had left it separate, it would have been really easy to see that I have a sine theta I can cancel. Because what do I have here? Everybody has a sine theta in common that they can cancel out. Now, if that's hard to see, you can pull out that GCF of sine theta in the top. If I go right back to where I was and I don't, you know, distribute him, then I see that I have a sine theta that cancels out because I've got 1 in the top and I've got 2 of them in the bottom. So I'm going to be left with 1 plus cosine theta over sine theta. And that's where you're going to stop. It's a strange stopping place. It's a strange stopping place, but that's it. So if I hadn't have multiplied it through, I could have just left it separate right here.
What would happen if you just simplified it from the beginning?
Well, you can't from the beginning. Oh, you mean got rid of this?
Yeah.
Well, then you're stuck here.
So
Yeah,
that
that's
is-
not the same thing.
Okay.
Yeah. So, yeah,
So it'd be wrong?
yeah.
How?
Because it's not the same thing. Yeah, this is what you want to get to. You want one nice little chunk in the bottom. You don't want two terms in the bottom.
But technically they are the same, because that equation is multiplied by 1.
What, this guy and this? No, they're very different. Oh, because he's multiplied by this one. You're multiplying by the conjugate though. So yeah, they're the same because you did stuff to them and got the same. But this is much more simplified. So this is the version you
Oh,
want.
so this is, it's just getting multiplied by the conjugate.
Yes, it's multiplying
Okay.
it by the conjugate.
All
Yep.
right.
See? Yep.
All
Yep.
right, all right. Sorry, I thought
That-
it was
you're
just
good.
a random term.
No,
Yeah,
no,
whatever,
no.
whatever.
I'm so confused.
Yes.
I'm not so confused.
That's okay.
Like, so what do you mean if you would have, distributed that first?
Oh, okay. So look at here. Here's what I did on my original version. Okay. This was my note and I didn't even read it. So here, I didn't distribute it. My numerator, I left them separate. I just set them next to each other because they're multiplied, but I didn't distribute it.
Oh, okay.
But I did distribute the bottom. And then I used Pythagorean and then I canceled. So good question. So what do I mean when I say that I don't have to do that? They're just sitting next to each other and then you can just cancel it out. Is that a little better?
You saw that beforehand.
Yeah, yeah, yeah. So practice this one. Yeah. You good? Okay. All right. So practice that one. That one's a little strange, you know, but that's probably the hardest one. It's not hard. It's just weird. And you don't know where to stop. Okay. All right. Now we got a hint. All right. Simplify gives us the hint. Use reciprocal and use quotient identities. Okay. All right. Let me check this out first. Okay. But we're going to go ahead and distribute first. Okay. So we're going to distribute through here first. All right. I have sine theta, secant theta, plus sine theta, cosecant theta, minus tan theta. Everybody okay with that? All right. Now let's figure out what they're talking about. Use the reciprocal and quotient identities. When it says reciprocal, this means change it to sine and cosine. That's what they're saying. Change it to sine and cosine. Okay, well, sine is sine, so he's fine. Secant's going to change to 1 over cosine. Okay, sine is fine. Cosecant's going to change to 1 over sine. And then I'm also going to change tangent, right? Because I want it in terms of sine and cosine. What's tangent? Okay, sine over cosine. There we go. Okay, so let's clean up a little bit. So this term can become sine theta over cosine theta. What about the middle term? What's going to happen to those? They cancel. Now it doesn't just go to 0. What does the middle term become? Plus 1. Good. And then over here I have minus sine theta over cosine theta. Everybody see where we're going here? Okay, so I have sine theta over cosine theta minus sine theta over cosine theta. What happens to them? Yeah, they cancel. They go to 0. What am I left with? 1. Okay, you may not get 1. You may get negative 1. You may get a 2. You may get something like that, but it'll be a nice little number. Okay. All right, everybody okay with that? This quotient identity was just what to do with tangent. That's his technically, that's the same thing. Okay. All right, 16 is a bonus because he's a little harder. Okay. All right, so all it tells you to do is simplify. There is no hint at all. It just tells you to take off and go. Okay, so what I noticed when I'm looking at this, there's a couple of ways you could approach this. So the top cosine squared theta minus sine squared theta. Gosh, he looks like he should be Pythagorean, but he's not, because there's nothing you can do to come up with that. There's no way to rearrange that. So he's not Pythagorean. Now the bottom, he kind of is a little bit, but still there's really nothing you can do to come up with that. They're both awfully darn close to Pythagorean, but there's really nothing you can do. So what we're going to do is we're going to kind of rely on what we've been doing all along, and that's turn everything into sine and cosine. When in doubt, turn it all into sine and cosine. So that's what we're going to do. Okay, my numerator is fine. My denominator, what am I going to do with tan squared theta? Sine squared theta over cosine squared theta, right? Be careful because he's squared. Okay. Now, I want to make one denominator in the bottom. So what can I change this 1 into? He could be cosine squared theta over cosine squared theta. And that way I can combine him with this guy. Okay, now again, this is a bonus. That's why it's a bonus. It's a little out of the box thinking there. Okay, see what we did there? We're just trying to get one denominator. Okay, so now my numerator, I haven't changed. I just keep writing him over. My denominator is cosine squared theta minus sine squared theta over cosine squared theta. Now, some of you might, depending on your algebra level, know the answer right from there. If you're not so sure about it, what can we always do when we have a complex fraction? Keep, change, flip. Just keep track of who's actually the top and who's actually the bottom. This is the top. This is the bottom. So we're going to keep cosine squared theta minus sine squared theta. We're going to change to multiplication. And then we're going to flip the guy on the bottom. Anybody see the next step? It's a big step. We got a cancellation. Everybody see that? This and this cancel out. And what are we left with? Cosine squared theta. So that was kind of a big leap there, but that's your bonus. Is everybody okay with that? We kept this. This we flipped, okay, because this is kind of like being over 1, if you like that better. We flipped this, and then we could cancel that, and all we're left with is cosine squared theta. Is that okay? Okay. All right. Okay, so that's all of your identities and proofs. And that brings us to our formulas that you see up here, okay? Sum and difference formulas. So let's go through those. Is it okay if I change the page? Okay, let's look at them. All right, first one says find the exact value using a sum or difference identity. Okay, so he's not on the unit circle and you can't use the calculator. So I want two angles that we can either add or subtract to come up with him. All right, so I'm more of an add girl, so I'm going to add some together here. Okay, so what I know is that I need two angles with pi over 12 that I can add together to get 11. Now the key to that is it can't just be any old thing, because whatever I use to add together to 11 has to be something that's going to reduce down to on here. Okay, so I came up with 8 and 3. All right. If I do that and I divide top and bottom by 4, I'm going to get 2 pi over 3. That's on the unit circle. And pi over 4. That's on the unit circle. Is everybody okay with that? If you want to practice those, there's more in our packet and then there's more in the homework, right? But we just chose two numbers that we could add together to give us 11 pi over 12, but they reduce down to numbers on the unit circle. So why couldn't I use like 10 pi over 12 and pi over 12? I can't reduce pi over 12, right? He's not even on here. That's not helpful. So whatever you choose has to reduce down to give you a denominator of 2, 3, 4, or 6, right? Okay, so what I'm actually going to find is these two added together. That's what I'm looking for, okay? It says sum or difference formula. There we go. So I chose the sum. So this is the one I'm going to be using. You're going to need all 4 of these on your test, but this is the one we're on now. So this first one is alpha. Second one is beta. Okay, so according to this, I want cosine alpha. Okay, that's going to be cosine of 2 pi over 3. He's going to multiply by cosine beta, which is cosine pi over 4. Okay, then I have a minus, and then I have sine alpha. Okay, so that's going to be sine of 2 pi over 3 times sine beta. Okay, so that's sine of pi over 4. Everybody okay with that? How we expanded that out? So whatever you choose becomes, the first one's alpha, the second one's beta, and you just plug them in. Now you go to your unit circle. Okay, so I'm going to have a value for this guy times a value for this guy minus a value for him times a value for him. And that's going to be my answer when I clean it all up. So I want the cosine of 2 pi over 3. Okay, here's 2 pi over 3. My cosine is negative 1/2. That's what goes in there. Then I have cosine of pi over 4. I find pi over 4. Here's my cosine. It's root of 2 over 2. That's what's going to go in there. Okay, now I'm looking for sine 2 pi over 3. Here's 2 pi over 3. Sine is root of 3 over 2. And sine of pi over 4. That's root of 2 over 2. Okay. Everybody see where we got all those from? Is that better? Yes, he's negative. Good. 1/2's negative. Okay, let's clean it up. All right. So here I'm going to have negative 1 times the root of 2. So that's negative root of 2 over 2 times 2, which is 4. Minus root of 3 times root of 2. So root of 6 over 4. Okay. And then they like it written as one numerator. And you're done. Okay. Just put them together over the 4 and you're all done. Sound good? Okay. So make sure you can do that with any of these 4, the cosines or the sines. All right, let's look at 18. 18 wants you to go the other direction. So here we go. We got to figure out which formula we're using. I'm not worried about the 12s right now. What I'm worried about is the fact that I have cosine, cosine, minus sine, sine. Okay, so I go up to my 4. I'm looking for cosine, cosine, minus sine, sine. Which one am I looking at? Top one. Everybody see that? It's the only choice. So it's got to be this guy. This is the one that I'm using because that's what they gave me. Cosine, cosine, minus sine, sine. Okay, so the first angle you see is alpha. The second different angle you see is beta. And we said we're using the top one, which was cosine alpha plus beta. Okay, so I'm going to plug in 3 pi over 12 for alpha and 5 pi over 12 for beta. Told me to add them together because that's the one that we came up with. That's going to be cosine of 8 pi over 12. Now I can reduce that. I can divide a 4 out of the top and the bottom. That's going to give me cosine of 2 pi over 3. And then I just go right to my unit circle and find it. So here's 2 pi over 3. Cosine's negative 1/2. There's my answer. Okay,
So you go all the way.
you go all the way to the unit circle and you find the answer. Yep. So you're going to have to identify one of these 4 going the other direction. Add or subtract the alpha and the beta depending. And then when you get that angle, either find the cosine or the sine of it on your unit circle. Okay, you do that? Okay, all right. Last summer difference thing we have to worry about then is number 19. Okay, we have the tangent one. Okay, so again, we want to go all the way and we want to find the value for this. So I notice, and this is the same one you're going to have, which is why I'm not going to waste your card putting up the difference formula for tangent, because you're not going to have it. You're going to have the sum formula. Notice it lines up perfectly. Tan plus tan, 1 minus tan tan. You're going to have it, okay? So what's my alpha going to be given this? 50. What's my beta going to be? 250. Okay, so my alpha's 50, my beta's 250. My formula says I'm supposed to add them together. Okay, so I'm going to have tan of 50 plus 250. I'm looking for the value of tan of 300 degrees. I go to my unit circle. Here's 300 degrees. Now remember, what's tangent? How am I going to find it given this? Y over x, right? Or sine over cosine. So I'm going to have negative root of 3 over 2 divided by 1/2. Okay. Negative root of 3 over 2 divided by 1/2. All right. So if I clean that up, these cancel. Then I'm left with negative root of 3. And that's my answer. Okay. All right. Let's do one, let's see, number 20 is going to be a bonus. So let's use that tan formula a different way to get our bonus. And then 1, 2, 3. Then we'll have 4 more. We'll have 21 through 24. If we don't get there, I'll just finish the recording and I'll send it to you, and then it'll be at the end of the recording, okay? If we don't get those. But all right, so number 20, this is your second bonus because your third bonus is a riddle. Okay, there's your third bonus. Or yeah, second bonus. Okay. So we want to use the sum or difference formula to find the exact value, okay, for tangent. Well, I just gave you the sum because I thought it'll save you time from putting up, having to deal with another formula because these are kind of big. So this is the formula we're going to use. You're going to come up with 2 angles that add together to be 105, okay, because that's who we have. So who do we think we could add together to get 105? Perfect. How about 60 plus 45? Okay, this would be our alpha, this would be our beta. Okay, that's who we're going to use. All right. So if we follow the formula, we want the tangent of alpha, so that's tan 60, plus the tangent of beta, that's tan 45, over 1 minus tan alpha, tan beta. Okay, so this is a bonus because you're going to have to multiply by a conjugate. You kind of have some heavy duty algebra, but it's not that big a deal. I mean, you did it all over my math lab. So, okay, here we go. So now we go to the unit circle. What is the tangent of 60? Okay, tangent of 60 is root of 3 over 2 divided by 1/2. What is that going to reduce down to? Root of 3. So tan 60 is root of 3 over 2 divided by 1/2 That's going to give me a very nice just root of 3. Okay, so that's what I'm going to replace tan of 60 with. Oops. All right. Now we need the tan of 45. Okay, so I go to 45 degrees. Here's my point. What's the tangent going to be for this point? 1, because they're both the same. So 1 over the other is going to be 1. Okay, now I'm going to fill this in the bottom. Okay, so 1 minus tangent of 60 times tangent of 45. All I did was fill it in. Okay, let's clean it up. Okay, so we went down that rabbit hole already where we thought maybe these were the same and we could pull out a -1 and cancel them out and all that, but we can't, right? I mean, we're just kind of stuck here. So we need to rationalize. This is why it's a bonus. How do you rationalize if you have more than one term? What do you have to multiply the top and bottom by? The conjugate. So what am I going to multiply the top and bottom by? 1 plus the square root of 3. That's kind of, the other problem we had that you guys didn't really like that much, this was kind of practice for that, right? We were multiplying by the conjugate. Okay, so here we go. We're going to get root of 3. What's the square root of 3 times the square root of 3? 3 plus 1 plus root of 3. There's my numerator. I got a lot of cleaning up to do, but there we go. Okay. Let's look at the denominator. I'm going to have 1. Okay. I'm going to have plus a root of 3 and minus a root of 3. So those are going to cancel. What's negative root of 3 times positive root of 3? -3. Good. Okay. Let's clean up now. All right. So what I notice is I have a 4 right here in the middle. I'm going to put it in the front. And then what's the root of 3 plus root of 3? 2 root of 3. Okay. And then what do I have in the bottom? -2. All right. Now here's that little magic triangle situation where every single term we have can be divided by the same number. And since we got this weird negative in the bottom, let's divide everybody by a -2. I'm going to get -2 minus root of 3 over 1, or just -2 minus root of 3. So again, that's a bonus because that's pretty involved. All right. Okay. I'm going to keep going as you guys file out because I don't want to make you late today, but I also just want, and then I'll send you the video because I want you to have it, but go ahead and cross through because you're not responsible for 25 or 26. Okay, because those are from 7-7. So you do not have those. All right. But then I'm going to keep on teaching on the video and then I'll send it to you. You may not need it because the answers are in the back. So you may be comfortable with how you get them. But if you need a little help, then you can watch me kind of go through it all. And then don't forget to have your index card ready. Oh, I do have some index cards. Hey, Abigail, would you do me a favor, honey? And in the cabinet right above the pencil sharpener. No, yeah, there's some index cards. If you guys want an index card, they're right back there by the pencil sharpener. Grab whatever you need. Okay. And get some more study guides. Oh, I was in the back. I parked in the back. Okay. So I'm going to keep on teaching while the herd of elephants leaves. So it may not be easy to hear, but here we go. Okay. All right. So number 21. We have information about alpha and about beta. Shh, you guys are so noisy. You're going to hear yourself laughing and cackling on the video. Okay. Okay. And we're going to find alpha plus beta. All right, maybe we'll just wait a second till the elephants leave. All right. Bye. Bye, dear. Bye.
I love you.
Love you too. Okay. Have a good day. Drive safe.
Of course. I might. Oh, I have one.
Yes.
I'll just
quarantine and he won't come back until Tuesday.
Thank you. You didn't tell me. Okay.
Does that work?
Okay. Then what we'll do is when he comes back next week, he'll take it, but I'll email him and tell him not to worry about it. But if you talk to him, tell him not to worry. I'll send him this. He can get a study guide, and then sometime at the end of next week, he can take it. Does that sound good? Okay. Thank you, dear. I appreciate it, Daisy. Okay. All right. So here we go. So we're gonna need all the information from alpha, okay? And what we notice is we have the quadrant. So alpha is between 0 and pi over 2. So if we go to our little chart, here's 0, here's pi over 2. So alpha is in quadrant 1. Okay, that's going to tell us that x and y are both going to be positive. Okay, so they gave us cosine, which means they gave us x and they gave us r. Okay, so we already know x is 2 and we know r is 5. So now we're going to plug it in. Remember, we're just going to use the little Pythagorean theorem, right, that you see here, that version, and we're going to come up with y. So I'm going to have 4 plus y squared equals 25. Then my y squared is going to be 21. I take the square root of both, and y is positive root of 21. Now that could have been negative root of 21, but this told us it was positive. Okay, let's now go through and do beta. Beta is located between 3 pi over 2 and 2 pi. So here's 3 pi over 2, here's 2 pi. That means beta is in quadrant 4. Okay, that's really important because that tells us y is negative. So they gave us sine, it's y and r. Okay, our y is negative 3 from quadrant 4. Our r is 4. Okay, we're going to use Pythagorean to find x squared. Okay, turns out in this case, our x squared is 7, and x is root of 7, and it's going to be positive because x is positive in quadrant 4. Okay, now we're ready to use this and find our answer. So we know that cosine alpha plus beta, according to our formula, is cosine alpha cosine beta minus sine alpha sine beta. All right, now we don't actually know what alpha and beta is, but we know the sine and cosine of each one from this information. So what we're going to have is in place of cosine alpha, we're going to have 2/5. Notice it completely replaced the word and the symbol. It's all gone. Now cosine beta is going to be x over r. That's root of 7 over 4 minus sine alpha, which is going to be y over r, times sine beta, which we know is negative 3/4. Okay, now we're ready. Okay, we're going to multiply. We get 2 root of 7 over 20 minus a negative is a plus, 3 root of 21 over 20. And then we're going to put it all over one denominator. We can't do the magic triangle. There's nothing we can pull out of all three, which means we are done and we finished. Okay, so that one's a little tricky. All right, let's look at the next one. Okay, 22. We're back to a sum and difference identity, but we had to wait on him because we had to get to the sum and difference formulas in order to do this. So what I notice is when I look at this, this looks a whole lot like this. That's the formula that we need. So if I look on my formula sheet for what we're going to need, that's equal to cosine alpha, cosine beta, plus sine alpha, sine beta. All right, now I'm supposed to prove the following, so I'm going to leave this side alone. I'm not going to touch it. and I'm only going to deal with this. And what I'm going to do is, this is my alpha, pi over 2, and this is my beta, theta. And I'm just going to put it in this form and see if I can't reduce it down to equal sine theta. Okay, so cosine of alpha means cosine of pi over 2. Cosine beta means cosine of theta. That's a little strange, but that's all I can do. Plus sine alpha, okay, remember alpha is pi over 2, times sine beta. Remember, beta is theta. Okay, trying to get this down to sine theta. All right, I go to my unit circle. Now I can't do anything about cosine theta, but cosine pi over 2, here's pi over 2, cosine is 0. Oh, that's pretty nifty. So that's a 0. All right, sine of pi over 2 is 1. Okay, so this is a 1. All right, 0 times anything is 0, so this goes away. 1 times sine theta is just sine theta. So there we go, and we did it. All right, okay, now we've got 7, 6. These are the double angle and the half angle formulas. We actually don't have any double angles on the test. We only have half angles. And so that's what I wrote on the board for you to use. All right, so there's 2 things we need to do before we start. First thing we need to do is figure out what quadrant 22.5 is in. Well, quadrant 1 has everything from 0 to 90 degrees. So that means this is quadrant 1. Okay, the reason I had to do that is because I need to use this formula for cosine for the half angle. And it has a plus or minus that sits out here. And I need to know, do I use the plus or the minus? Well, cosine in quadrant 1 is positive, so I'm going to use the plus. Okay, now the second thing I need to do is find theta, because this is theta over 2. And that's not what I want. I want plain theta. So I'm going to multiply theta over 2 by 2. So if I multiply both sides by 2, I'm not squaring it. Okay, I'm multiplying it by 2. I find that theta is 45 degrees. Okay, so what I'm finding is 1 plus cosine of 45 degrees over 2. That's what I'm dealing with. Okay, so I go to my unit circle. The cosine of 45 degrees, according to my unit circle, is root of 2 over 2. Here we go. All right, I want to clean up now. So what I'm going to do is combine the numerators, which means I'm going to take this 1 and make him 2 over 2. So that I have 2 over 2 plus root of 2 over 2 all over 2. Okay. I'm going to keep going. I'm going to get 2 plus root of 2 all over 2. And that's all over 2. A lot of 2's. Now I'm going to keep, change, flip. So I'm going to keep my numerator, which is actually all of that, change to multiplication, and flip this 2 on the bottom. Now remember, he's still under a radical, and I'm going to flip him. So this is going to be 2 plus root of 2 over 4. I won't take off points if you leave it like that, but we do know the square root of 4 is 2. So this is actually the final correct answer. But if you leave it like this, I'm okay with that. I'm thrilled you got there. But this would be what we're actually looking for. Okay. All right, last problem. And I kind of wrote all over the study guide. All right, tan of 105. So again, there's 2 things we need to do. First of all, we need to figure out what quadrant is 105 in. Okay. Well, 105 happens to be in quadrant 2. All right. Next thing we need to know is find theta, because this is theta over 2. So I need to multiply 105 by 2, and I'm actually looking at a theta of 210. Okay, now what I'm going to do is go find my tangent theta over 2 formula, which according to what I had left you on the board is 1 minus cosine theta. That's where I put in this, all over sine theta. Now I actually didn't even need to know the quadrant of this because the formula I chose didn't have a plus or minus outside. So it's fine just the way that it is. That was just kind of an extra step. Okay, here we go. I'm going to go to my unit circle and look up 210 degrees. Cosine is negative root of 3 over 2, and sine is negative 1/2. So I'm going to have 1 minus negative root of 3 over 2, which means plus, over negative 1/2. Okay, I'm going to do kind of what I did here again, where I'm going to change this 1 to 2 over 2. That's going to give me 2 over 2 plus root of 3 over 2, and the whole thing is over negative 1/2. Okay, clean it up. I have 2 plus root of 3 over 2, all over negative 1/2. These are going to cancel, which is really nice. And then I just have this negative 1 in the bottom. So I'm going to take this negative and I'm going to distribute it through the top, since I don't have a denominator anymore. So your final answer is negative 2 minus root of 3. That's what you're looking for. Negative 2 minus root of 3, because you distributed this negative from the bottom. Okay. And then that ends your test. So that's everything you need to make 100. I think you're going to be fantastic. And I will see you on Friday. Please email me or text me if you have any questions at all. Okay, bye-bye.